video is the structural design analysis of an as-built plan. But before going to the computations, i-discuss ko muna yung ilang basic structural principles or concepts sa pinakasimpleng paraan na kaya ko and hopefully, mauunawaan ng karamihan. So, let's proceed with our agenda for today, which consists of 3 topics. First is the structural forces. Next is structures and structural members and elements. And the topic 3 is the introduction to structural design analysis. So, ano nga ba muna ang structural design analysis? Structural design analysis is the methodical investigation of the stability, strength, and rigidity of structures. The basic objective in structural analysis and design is to produce a structure capable of resisting all applied loads without failure during its intended life. Kung once in your life naging curious kayo paanong sobrang tibay pa rin nakatayo ang mga building na mayroong napakaraming palapag tulad ng mga condominium towers at of course marami rin ang occupants nito, sa structural design analysis natin maunawaan kung paano naging posible yun. Dahil dito, inaalam ng mga structural engineers yung various loads or yung intended loads na dadalhin ng structure. And once na na-consider na and na-establish ng mga ito, dito na isinasagawa yung mga computations or calculations to determine the response of the members or elements of the structure to those loads. And based nga sa definition, to determine the most sound design na kayang i-resist ang mga epekto ng loads sa structural members and the overall structure at magsasatisfy sa safety and integrity of the structure once it is used for extended function. Based pa lang sa definition and explanation, sobrang crucial ng structural design analysis dahil kaakibat ng layuning makapag-produce ng structure ay ang safety ng occupants. Kaya, tulad ng sinabi ko kanina, susubukan kong ipaliwanag muna yung mga tinatawag nilang basic principles or concepts of structural design analysis. So, before our first topic, let's define structure. Structure refers to a system of interconnected structural members used to support external loads. Our first topic is structural force. Principles and concepts. Equilibrium of structure. One of the main structural principles is that elements must remain at rest when subjected to or acted upon by forces. Technically, if a body is in equilibrium, it means it is not accelerating. And from our physics class, alam natin na yung acceleration ay palaging associated with an unbalanced force on a body. At yung relationship between acceleration and that force caused by that acceleration is given by Newton's second law, which states that force is equal to mass times acceleration. Or in civil engineering, mas madalas na encounter ito as force equals the mass times the gravity. Halimbawa, di ba yung gravity is a force constantly applied sa tao man o sa bagay. Pero hindi naman tayo nag-accelerate. So, bakit? That is because of Newton's third law of motion, which states that action and reaction are equal and opposite. In this case, or in that example, binabalance out ng constant reaction force from the ground yung force na ina-apply sa atin ng gravity, thus keeping us in place. Force in that example is equal to 0, pero hindi ibig sabihin nun na wala yung applied force. And based sa binigay kong definition and explanation about structural design analysis, equilibrium of structures is really one of the most important structural principle that is always needed to be considered when designing to ensure that we will arrive with the structural design that can withstand all the applied loads it is subjected to. And hindi naman na kailangan to, but sasabihin ko na rin na yung accelerations sa structures na na-encounter ay hindi literal na mag-accelerate yung structure. Ang tinutukoy dito ay yung dynamic loadings such as wind or earthquake loads na nagpapagalaw sa structure at madidiscuss sila later on this video or in the next videos. So, going on, imagine magtatayo ka ng structure sa area na prone sa earthquake. Pero, hindi mo pala na-consider sa structural design analysis yung seismic load or yung earthquake load kung na-approve yung computations na itayo yung structure, and wag naman sana, pero kung magkaroon ng lindol, malamang guguho agad yon kasi hindi naman naisama sa computations yung strength na magre-resist sa structure, sa earthquake load. Syempre, hindi natin gusto yon dahil una, malaking gastos at ang pinaka-importante, iniiwasan natin ang may mapahamak. So, paano ba natin malalaman kung in-equilibrium yung isang structure? In-equilibrium ang isang structure kapag yung forces in the orthogonal direction or forces along x, y, and z axis ay of course equal sa 0. The same thing goes for the moment or the force that causes rotation. Next is the properties of forces to be considered. First is the magnitude or the size of the force. In SI units, this is in Newton or kilonewton. The direction of the force and the location where force is applied. Bakit mahalaga to? Let's look at the structure on the right side and its free body diagram. Siguro familiar na tayo sa free body diagram sa P6 pa lang. At alam natin na kapag magdodrawing neto, lahat ng forces acting on that body or that structure ay dapat naka-indicate using arrows. Kaya dito pa lang ay may onting idea na tayo sa properties ng force. So, yung 10 kilonewton per meter is called uniformly distributed load. This means that for every meter of beam length, 10 kilonewton of force is spread out evenly across that length. While yung 30 kilonewton at point C is a concentrated load. Ito yung mga applied loads na nagkakos ng reaction forces sa support. Itong part na to at point A ay fixed support, at point B is a hinge, and at point D is a roller support. Yung reaction forces na napuproduce nila ay yung forces na nire-resist nila. Halimbawa, sa point D, yung roller support. Kaya, walang horizontal force doon dahil hindi naman niya wala naman siyang nire-resist na na horizontal force. It can freely move sideways unlike sa fixed support. So, going back to the properties, mahalaga yung magnitude, direction, and position where the load is applied dahil halimbawa, kung yung upward force sa fixed support at roller support ay ginawang downward force, malamang walang magre-resist sa uniformly distributed load at concentrated load. Then, sabi nga ng prof namin, by tingin-tingin method, the forces along y-axis will not be equal to 0. Therefore, the structure is not in equilibrium or not stable. Moving on to the classification of the structural forces, structures are designed to sustain various types of forces that could act on them during their lifetime. These forces can be classified into two types. First is the external force. Stresses that act on a structure from outside of the structure, and it includes the applied loads and the reaction forces. Ito yung kanina pang nababanggit ko sa mga first topic. So, under the applied loads, nandoon yung dead loads, live loads, and environmental loads. So, yung dead loads or the static loads
lagi nating tatandaan na ito yung mga structural load na constant ang magnitude, direction, at position over time. Sa madaling salita, hindi nagbabago ito. Included dito ay yung self-weight ng structural members and yung weight of the structure itself. Kasama na rin dito yung loads ng fixtures na permanently attached sa structure. Next is live loads or the dynamic loads. Ito naman yung mga loads na changing o non-permanent sa structure. Kabilang naman dito ay yung loads na created by the storage of furniture and equipment, occupancy o yung mga tao na titira or gagamit nito, and the impact. Next naman na yung environmental loads. Under dito yung kaninang binanggit ko na wind or earthquake loads na and rain loads and flood loads. Sa ibang bansa, kasali rito yung snow loads. Pero since nasa Pilipinas tayo and hindi naman nag-snow dito, hindi na ito sinama sa structural code of the Philippines. Then, the reaction forces ay yung mga forces na ina-exert ng supports on the structure and have a tendency to prevent its motion and keep it in equilibrium. Yung mga structural loads na binanggit ko kanina, kababanggit ko lang ay hindi kung saan lang kinuha. Nadidetermine nga ito based sa local structural code and specifications na sinet at sinusunod within the country. Dito sa Pilipinas, ang sinusunod ay yung National Structural Code of the Philippines 2015 at yung mga table for dead loads and live loads and other information regarding loads ay makikita sa chapter 2 nito, which is the minimum design of loads. Example of illustration by these loads is on the left side, and yung image naman on the right side are the list of loads na kinonsider sa computation ng structural design analysis of the as-built plan na explain sa mga next videos. So, base nga sa reference code nito, nakalagay National Structural Code of the Philippines din yung yung reference. So, next is the internal forces or internal forces are the forces and couples exerted on a member or portion of the structure by the rest of the structure. So, this type of force is not visible unless, for example, in this sample beam. Sa P-body diagram nito, magka-cut tayo ng section at a specific point or sa case ng first figure, nag-cut at point B or sa hinge na part. Since the hinge can rotate freely, ibig sabihin, hindi nagre-resist ng rotation, therefore, walang moment. Kaya, forces along X and Y axis lang ang internal force. And sa second figure naman, nag-cut at point C, wala nang hinge doon. So, resisted na ang rotation, kaya bukod sa forces along X and Y axis, mayroon na ring moment force. Then, the sign convention on the right side provides the direction and position of the internal forces at a cut section. Sa statics, halimbawa is this beam, kapag kinat mo siya at a certain point or part, and kinonsider mo yung left side of the beam for the computation or analysis, ito yung direction ng mga forces na dapat naka-indicate sa FBD. Of course, yung forces upward and forces to the right are positive. Forces downward and forces to the left ay negative. Counterclockwise movement is positive. And yung clockwise naman ay negative. Next is the classification of internal forces. Depending on the direction in which they act, internal forces can be classified as compression, tension, shear, torsion, and or bending. So, compression, from the word itself, it is a force that squeezes or presses an object together. Tension is the force that stretches apart an object, causing an expansion. Shear force, which is denoted as V in the computation, is a force that pushes the object in opposite directions and cuts this object by sliding its molecules apart sideways. Torsion is a force that twists an object, and bending is a combination of tension forces and compression forces in an object. Bakit mahalagang ma-discuss itong mga forces and loads? Dahil based nga sa definition structural design analysis, kailangan natin malaman yung magiging epekto ng mga loads and forces sa structural members at paano sila magre-respond sa mga ito. And from that information, madedetermine natin through computations or calculations yung strength and stiffness of each member or element and their appropriate sizes or dimensions na makapagbibigay ng equilibrium sa structure. To define, stiffness refers to a member's ability to resist deformation when subjected to a force. While yung strength naman, nagme-measure sa maximum load na kayang i-withstand ng structural members or elements before deforming or failing. Then, yun nga, to arrive at a member's strength, engineers would calculate its bending or shear stress, depending on what stresses are expected to act on a member. So, our next topic is the structures and structural members. First is the types of structure. Structural system. Combination of structural elements and the materials from which they are composed. Another important structural principle is that the structural system of a building is designed to transmit the loads and forces safely to the ground without damaging the building. Yung ilang structural system ay based on a single material or a combination. For example ay concrete, wood, or the steel structural system which consists of horizontal steel beams and vertical steel columns. Or in combination, it is along with horizontal floor plan of steel and concrete. Possible din na magkaroon ng higit sa isang structural system. For example, ay yung concrete foundation supporting as a light wood frame superstructure. So, on the right side are the illustrations of structural system, the frames, trusses, arc, and cables. Then, next is superstructure. Superstructure is a building's vertical structure above the ground. Pinakasimpleng paliwanag na binigay sa amin dito is ito yung building or parte ng isang building resting above its foundation. And obviously, this superstructure consists of structural members. And ano-ano nga ba yung mga structural members na yon? So, structural members make up a structure which can have different forms or shapes depending on their functional requirements. So, yung mga structural members na narito ngayon sa PowerPoint or presentation ay yung mga members na i-discuss ang computations of design in the next videos. And through these structural members, susubukan ko na rin i-discuss briefly yung load transfer in a structure. First is yung slabs. Slabs span horizontally between supports used as floors and sometimes as roof systems. So, slabs ay yung plate elements of a structure na usually nagke-carry ng vertical loads. And due to a large moment of inertia, under horizontal loads such as wind and earthquake, they can carry quite large amount of this and then transfer them to the beam. So, next ay yung beams. They are the horizontal members which transfer loads to supports. The beams may be supported by other beams or may be supported by columns, forming an integral part of the frame. The next is columns. They are vertical members which transfer compressive loads to the foundations. Although lahat ng design of structural members ay mahalaga, kumpara sa beams and slabs, mas mahalagang parte ng structure ang columns. Because if one beam fails, it will be a local failure of one floor only. Pero kung isa sa mga column ang nag-fail, it can lead to the collapse of the whole structure. Then, the last structural member in the load transfer is the footings. Footings transfer load from the structure to the foundations. And yung loads na galing sa columns and walls are transmitted to the solid ground through the foundations. And yung foundations, itatransfer yung load safely sa ground. Then, so, yung illustration ng load transfer is illustrated in this image. In this example, the gravity load path is shown. So, down to our last topic, which is the introduction to structural design analysis. So, structural design process. A structural design project may be divided into 3 phases. First is planning, design, and third is the construction. Pero ang pinaka-focus natin ngayon ay sa design because this phase involves a detailed consideration of the alternative solutions defined in the planning phase and results in the determination of the most suitable proportions, dimensions, and details of the structural elements and connections for constructing each alternative structural arrangement being considered. So, dito nga yung mga computations and calculations for that na i-discuss sa mga susunod na videos. So, for the philosophy of designing, ito yung na-explain ko na kanina sa pinakaunang part and uulitin lang natin dito. The philosophy is the structural design of any structures first involves in establishing the load and other design conditions, which must be supported by the structure and therefore must be considered in its design. Next naman is yung elastic design yung traditional basis of design, and this is based on allowable stress intensities, which are chosen in accordance with the concept that stress or strain corresponds to the yield point of the material and should not be exceeded at the most highly stressed points of the structure. Ang disadvantage ng design na to, ng stress allowable design na to, ay hindi niya kayang i-provide yung uniform overload capacity for all parts and all types of structures. So, next is yung newer approach, which is called strength design in concrete and plastic design in steel design literature. In this approach, the anticipated service loading is first multiplied by a suitable load factor na ginagamit para i-increase yung amount of the anticipated service loading on the structure para ma-account yung possible load increase during the building's lifespan. And in this approach, for reinforced concrete design, RCD, theoretical capacity of a structural element is reduced by a capacity reduction factor. Ito yung para mag-provide ng small adverse variations in material strengths, workmanship, and dimensions. So, yung load factors and strength reduction factors sa RCD or reinforced concrete design, in the strength design method, the safety of concrete structures is ensured by using load factors and strength reduction factors. So, based on the National Structural Code of the Philippines or NSCP 2015, ito yung combination of common load combination for most applications. Yung nasa yung 1.2 sa harap ng D or 1.6 sa L or yung dead load at live load is the load factor na binanggit kanina. Then, the strength reduction factors is also from the NSCP 2015, the design strength provided by a concrete member, its connections to other members, and its cross-sections in terms of flexure, axial load, shear, and torsion shall be taken as the nominal strength multiplied by a strength reduction factor. Then, ito yung mga values. So, na-discuss ko na rin to dahil in the next videos, magagamit natin ito ng madalas for the computation. So, para na lang mapamiliarize tayo. And that's all for this video. Thank you for listening and I hope may natutunan kayo or maayos yung pagkaka-explain ko at naunawaan ng karamihan. Thank you.